We're going to go through now endocrine system worksheet. There are less MCQs from last week. Okay, so first question, which one of the following examples of negative feedback is incorrect? Okay, you just take note of the word incorrect. So that means 3 options are correct. The word in option A, cessation, means to cease, means to stop. Yeah? So cessation of shivering when body temperature has increased back to normal. It means shivering stops when body temperature has increased back to normal. Is that correct? Yeah. Right? When body temperature increase back to normal, you don't need to shiver anymore. Correct. Decrease in production of sweat when body temperature has decreased back to normal. That's true also. If your temperature decreased already, you sweat, don't need to sweat so much. Decrease in the release of antidiuretic hormone when water potential has increased back to normal. Same idea here, this is correct. Last one is the weird one that I think will confuse you if you forgot the function of insulin. Using what Shafika taught us? Glucagon. We use it when glucose is not there, right? So, when will we use insulin? We use insulin when blood glucose levels are high. Here, this option says, you will decrease the release of insulin when glucose levels increase back to normal. Okay, that is rather odd because the function of insulin is to decrease glucose levels in the first place. Yeah? Okay, so to answer this question, you need to know the function of insulin. Then you know that it doesn't match with the second part of the question, the option. Let's go to question 2. Question 2 asks you, which graph shows how glucose level changes after a meal? The correct answer is... What do you think? Soya? Wenxin? Okay. Wenxin is right. Okay. No lah, Soya is also right. Okay, answer is A. After a meal, the graph should go up because your food got digested, enters your bloodstream, but because of negative feedback, homeostasis brings it back down. B is very odd. After you eat, blood glucose level increase. After 1 more, increase some more. Okay, that shouldn't happen. So most like positive feedback. C is not correct because after you eat, blood glucose level shouldn't decrease immediately. In fact, this one decreases below the normal levels, which is very odd after you eat. Look at D, this is also not correct because after you eat, the first thing that happens, sugar level shouldn't decrease. It should increase first. How Yang, you have a question?
What's the point of saying they fast first?
Oh, what's the point of, good question. What's the point of saying they fast first? The whole point of saying that is so that when we say someone fast for several hours, that means the starting point of glucose level is your normal level. Okay? Fasting means that whatever you see at the start of the graph, there is normal blood glucose levels. It is important because if I put this person starved himself for many days, the blood glucose levels were started off way lower than what you see in the graph. Okay? And if he ate already and he eats some more, the blood glucose level actually would have been higher than normal. So what you are seeing there is the normal level. Alpha, okay? Okay. Next question, question 3. Very interesting question. It depends on your understanding of anatomy. They ask you, okay, out of these types of glands, okay, it's not 4 types, only 3 types here. The arrow shows how their secretions pass from them into other parts of the body. This question is a very good question. They want to test your understanding of exocrine and endocrine glands. What's the key difference between exocrine and endocrine glands? Exocrine glands got ducts. Endocrine glands, no ducts. The next level they are trying to test you is your understanding of which glands in your body are endocrine and exocrine in nature. Let's look at the 3 column headers. Insulin. Insulin is secreted by the alpha? Okay, good, yeah. By the beta cells of the organ pancreas. Estrogen is secreted by Shafika? Ovaries. Saliva is secreted by Wenxin? Salivary glands. Out of all 3 of them, which one is exocrine in nature? It's the salivary one, right? Squirts into your mouth directly to the target site. So, out of the three options, which one best represents the salivary glands? It will be the option with number 1, right? Next, estrogen. Okay, the ovaries is it is an endocrine gland. Okay, because estrogen is secreted directly into the bloodstream. So 3 will be the best answer for estrogen. The interesting one is insulin. Then I draw you back to your SLS, where we learned about pancreas being both an endocrine and exocrine gland. This example here shows a very classic example. Number 2, you see that gland attached to a duct. At the same time, it has blood capillaries running through it. So it must be secreting both hormones as well as something directly to the target site. And that is a pancreas. Pancreas is both exocrine and endocrine in nature. Okay, so B. Next question, question 4, shows you 2 graphs, one of a healthy person, one of a person with condition X. At the point where you see that spike up, okay, likely it's because that person ate something. So the glucose levels increase all the way to that point. Okay, but you see the difference between X and a healthy person? The blood glucose levels decreases very, very, very slowly. Compared to a healthy person, it's a sharp decline. They ask what is a possible treatment for this condition. Perhaps the first question we should ask is, what is the condition person X is suffering from? Okay, what do you think? Yeah, the only one you know of lah. Diabetes. Diabetes, regardless of type 1 or type 2, blood glucose levels will take very long to decrease back. So, what is the treatment for such a thing? You will require regular insulin injections, because the role of insulin is to reduce blood glucose levels. You shouldn't be eating glucagon tablets, because glucagon helps to increase blood glucose levels. You shouldn't be taking in more glucose, because you already have a problem reducing your glucose levels. Transplanting the liver of a horse into a person. I think the problem with this statement is the horse part. Yeah, we will want to transplant from human to human. Okay, cannot, because if you transplant, your body will reject it. You will see it as a pathogen, like bacteria or virus. Immune system will start to destroy it. Even person to person, blood type must be the same before it even works. If not, the person's body will start to reject. Let's go to question 5. Question 5 is a very unique question. It blends 2 topics together, endocrine and nervous system. If you should have done your term 1 review. One of the questions was comparing endocrine and nervous system. Yeah? So this is a compressed version, summarized into a MCQ question. So the part at Y is asking for the similarities between these 2 systems. And the similarity is that they are both used for coordination. Z, nervous system, it can be voluntary or involuntary as we have learned. In X, it's always involuntary for the endocrine system. Okay, that's all the MCQs for this time round. We go to the structured question, only one today. The structured question shows you a cross-section of a bunch of cells. They even say it's the islet of Langerhans, so we know it's the pancreas. They show you blood vessels and they show you a main duct. They ask you one protein which can be found in the main duct after a meal. If you had written insulin or glucagon, you will not get a correct answer, because insulin and glucagon should be secreted into the bloodstream. Yeah? No point secreting these hormones into your digestive system. Okay? It will be digested by the proteases. So instead, any enzyme they can think of that the pancreas secretes is an answer that will be accepted. Next, they ask you for the organ through which the duct will empty these enzymes into. If you could remember exactly which part of the small intestines, duodenum will be the answer. If you cannot remember, small intestine is also okay. We go to BI. They ask you which one will be secreted after a meal. I still like what Shafika taught us. Glucagon is secreted when there is no glucose or very low glucose in your bloodstream. So if you have a high amount of glucose after a meal, you want to use insulin to bring it down. The next part asks you, then how does insulin work? What is the effect of insulin in your bloodstream? You see all these options here? They are the options you can find in your textbook in that table that shows you all the various things that can happen. Yeah? But the classic ones that you can look out for is that insulin decreases blood glucose concentration by increasing the permeability of cells to glucose. If cells can reabsorb glucose from the bloodstream, then you have less glucose flowing in your bloodstream. Okay? And then there are the two options you can write down too. Do you need to write all? You see 3 marks, right? Yeah. Okay? So the 3 marks, 3 points. This time round, we'll give 1 mark for the fact that you say that insulin helps to decrease blood glucose concentration. Okay? Then you give any of the 2 out of the 3 options they gave you. In fact, in your textbook, they gave you many options of how insulin can work. You can give any of the 2 will do. Okay? Last one, asks you to complete the graph. Okay? What will the graph look like? Okay, y'all draw for me. I'm going to invite some of you on the board. Okay, can I invite Ziwei? Okay, so the graph goes something like that first. This is where the meal is eaten. Okay, first person, I'd like you to draw what will happen in a normal human being after a meal. Ziwei, can you help me draw for a normal human being? Thank you. Ziwei makes it go up, that's correct. And then goes down. Okay, thank you, Ziwei. So Ziwei has made it go up because after you eat a meal, digest, blood sugar level should increase. It will decrease again, but decrease to where? Okay, so Ziwei tries to draw it back to the normal levels. Okay, thank you. So now what will it look like for a person with diabetes? So yeah. Can I give you the red marker? Thank you. And actually, if you don't know how to do, you refer to the previous questions. I've given you the answer. Yeah? Okay, thank you, Soya. So it will still increase. Increase to where? Increase to the same amount, because you eat the same amount of food. Okay? Okay, so for Soya made it kind of stagnant. Okay? In reality, it is not so much stagnant. You will find that it's gently sloping down. Okay, so make it gently slope down. Why? Because your body is still using glucose. Right? When you breathe, when your heart beats, still need the mitochondria still need the glucose to be able to release ATP. Okay? So it shouldn't be a full plateau and never should it go up. It should be slightly tapering down. Okay? Very good. Very easy. Yeah? Okay, so this chapter, what should you focus on? You focus on this case study of how insulin and glucagon regulates blood glucose levels. If you understand this very well, actually endocrine system is clear already. You see the other sample questions about how we differentiate endocrine and exocrine system. What is negative feedback? These are all more general questions. Okay, but our favorite case study is the only one we taught you. Okay? Okay, today is a very short console. Thank you so much.